All right, let's jump into the lecture then. So we're going to start working through digestive anatomy. And it's going to be a little different from years past. I'll just start sharing my screen here. All right. So I was saying it's going to be a little different from the past because usually this has a large histology component. And that component is now going to be taught within your lecture when you have it. So that'll be part of your lecture material. You'll still get it, of course, and have to learn it, but it just won't be part of your lab practical. Okay. Some updates that Manny had sent. There's a new version of Complete Anatomy. Make sure you're running that before taking practicals. And you should be able to use it on a PC now as well. And just keep sending me your scores when you're done taking those practicals. That way I got a nice record of it in case the dashboard is ever down. Oh, these materials here for module 3, digestive system anatomy, those are now posted on Canvas, and your practical should be active and ready to go too for when you feel ready to take it. You can search for the digestive anatomy slides once you're in there by just typing in GI mat, so no space. And if you put that in there, then you can select all those slides, Manny put that prefix on there so you can sort through them quickly. All right, so we'll begin with digestive anatomy. The two of you that are here, feel free to pop in at any time with questions or type in the chat. Okay, we can keep this pretty informal since there's so few of us. All right, so digestion begins within the mouth. So we use our teeth, which we formally call dentition, and that allows us to, chew up our food, mastication. So, whoops, here we have I'm gonna bust out my marker for us, our pen. Okay. That is not drawing, there we go. All right, so on the crown of that tooth, the crown is what is found above the gum line and is exposed. It's kind of like the apical surface of that tooth. And the crown is covered with enamel. And enamel is actually the hardest substance within your body. And that makes sense because we're constantly crushing and breaking down food in our mouths. We got to have something pretty tough in there to handle all that. Underneath that, we have dentin. And dentin is like bone, but it's harder. So that gives us the structural support of that tooth. What else do I want to point out here? Well, if we experience damage to the dentin or the enamel of the tooth, or even the cementum down here, which is a term you don't need to know, that's just a harder material that protects the roots. So once we're down into the gum, the cementum, if there's damage to any of those three structures, that's what we call a cavity or a dental caries. So you may have heard that term. That is CARIES, dental caries. That does not look great, but dental caries. And we get dental caries from when bacteria start breaking down carbohydrates in the mouth, and they release acid, and that acid can eat through the enamel or the dentin, and then gives rise to dental caries or cavities. In the center of the tooth, we have the pulp. It's a soft tissue. And then in the center of that soft tissue of the pulp, we have the root canal. So a root canal is not only the procedure where they drill that out should that become infected, it's also an anatomical part of your tooth. And you can think of the pulp and the root canal kind of like the shaft and then the internal lead of a pencil. So that root canal would be analogous to the lead of a pencil. And that's where we have a big collection of nerves. Okay. And then to the specific dentition themselves, we have I was actually pre-dent. Obviously, that didn't pan out. Kind of lost interest pretty quickly after graduating. But we have the incisors. So the incisors, you have your central incisors, upper and lower. Okay, those are your two front teeth. Next to those, you have your lateral incisors. Okay. Following those, we of course have our canines, and that's followed then by your premolars and then your molars. The cross section of a tooth, we can see those structures we talked about previously, the enamel, and then under the gum we'll have the dentin, and here's that center, the pulp cavity, that soft tissue that would have the root canal running through the center of that, like the lead of a pencil. So we begin digestion in the mouth, mastication, we start breaking up that food. When we break up the food, we expose it. We bring in saliva and mix it with that food. And in that saliva, we have enzymes. So we should talk a little bit about salivary production. We'll talk more about specific attributes of saliva and breakdown of foods within lecture. But here we're just going to review the different salivary glands. And we'll start with the largest of those. We have the parotid salivary gland. That's the largest, and it's a little bit anterior, okay, and then inferior to the ear. And this is going to produce the majority of the enzyme amylase. You may have heard of that enzyme before. This is going to break down starch within the mouth. So the mouth, we actually have both chemical digestion occurring. We're going to start breaking down macromolecules like starch, carbohydrates, and then as well as a physical digestion where we masticate and break down that food. So this is going to produce and secrete amylase. Next, we have the submandibular salivary gland, aptly named. It's found beneath the mandible, submandibular. And if those of you that are familiar with gleeking, if you've ever done that, where you kind of rub your tongue along the surface of your mouth and get that saliva projection, that is due to the submandibular salivary gland. And this gland produces the majority of the saliva. It produces the most saliva. And that's followed by the sublingual gland. And you can guess based on that name, found below the tongue. So these last two glands, the sublingual and the submandibular, they produce more of a mucus type saliva than the enzyme containing saliva. So most of that amylase is going to be produced from parotid. A little bit more anatomy here within the oral cavity of the mouth. Pretty straightforward. We have the hard palate and the soft palate. And if you've ever, I guess, two options you can feel where your hard palate transitions to your soft palate as you run your finger along the roof of your mouth, or if you've ever chewed down on something wrong and it slid off your hard palate and hit your soft palate. We know that Captain Crunch is notorious for destroying your hard palate. Then at the back of the throat, you got the uvula, right? A little dangly thing there, prevents food and liquids from entering into the nasal cavity when we swallow. Onto the different papillae on the tongue. So most people kind of confuse these with the taste buds, right? So you look in the mirror and you can see the little papillae. It's not quite the case. The papillae house the taste buds. There are three different ones that you need to know. So first of these, probably the easiest, fungiform. And you can imagine fungi there, that prefix. These kind of look like mushrooms, right? So we can see that characteristic mushroom-like top. Okay. Those are fungiform, mushroom-shaped, and each of those contain at least a few taste buds, and they are located on the tips and the sides of the tongue. Then we have the foliate papillae. Foliate meaning like foliage, because whoever discovered them thought they had like leaf-like ridges. Okay. So you can kind of remember them that way. They're located on the posterior lateral side of the tongue. Back here. We'll look at another slide of how they appear within complete anatomy next. And then the last one you need to know are the valate papillae. Okay. And these are easily distinguished. You can see them here. These are these large circular-like papillae here found at the back of the tongue. So they're really easy to pick out. They are the largest, but the least numerous. And because they're the largest, they contain the most taste buds. They're located in a row at the back of your tongue in about, I don't know, 10 to 12 of these in a row. Those are the valate papillae. Okay. So in complete anatomy, it's going to look something like this. We got our fungiform here, characteristic mushroom-like top. The large valate at the back of the tongue. Everett, I'm in a lecture. And then here on the side, we have those foliate. They don't really look like leaf-like ridges, but it's what you need to know. Okay. All right, 1 second. Everett, beat it, buddy. I'll be out in a second. Yeah. Go ask your mom.
You don't know how to.
Well, I can't do it right now.
Because it's your fault.
Yeah. Okay. Everett, I don't have an account for that one. I don't have an account for this. Everett. All right. I'll be right back. Oh. Oh. All right. Sorry about that. So those are the papillae of the tongue. Next, we'll move on into the esophagus. And all this is part of your GI tract. It's this long continuous tract from the mouth to the anus, hollow area. And you can imagine technically then that that's exposed to the external environment because it's your mouth, external, and then it goes to external at the anus, and it's a long hollow tube. It has a lumen. That's the hollow center. And there are 4 layers to the GI tract wall. And we'll learn those more in depth in lecture, but I do want to run through them quickly here. The first layer, the innermost, so closest to the lumen then, is the mucosal layer. And this is where absorption and secretion occurs. So we're going to need absorption of nutrients along the wall of the GI tract in many areas as that digested material moves along. And we're also secrete things as well, like mucus, to keep things sliding through. So that's the mucosal layer. It's made up of 3 layers, but we'll talk more specifically about that in lecture. The next layer is the submucosa. So it's easy to remember, sub meaning beneath. So that's the next layer. It's a little difficult to see on this slide actually, but it's this pinkish area right here. Right? So the light pink area underneath the mucosal layer. Lots of vessels and nerves are found within this layer. And then we have the muscularis. This is mostly 2 layers of muscle. We'll talk about an exception shortly. And the first one kind of follows the circumference of the tube, the inner circular layer. So those muscle fibers, or that muscle is going to be oriented kind of in a circumferentially way following the circumference of that tube. And then the next layer, the outer layer, is oriented longitudinally, excuse me. Okay. So the different orientation of those muscle fibers we'll see it will allow for different multi-directional contractions. Okay, so we can shorten that tube, and then we can also contract and shrink the radius of that tube as well, or the diameter. And then the outermost layer is the serosal layer, and this secretes a serous fluid. Serous fluid helps, it's a lubricant, so it prevents friction between the layers of the GI tract, between the GI tract and the other organs around it. All right, so if we move from the mouth now into the esophagus, it's not shown here, but we can break the esophagus up into a couple different portions. So the first here, up above the oral cavity, would be the nasopharynx. I'm just gonna write naso, and then you can add the pharynx there, just like the other 2 of these. So nasopharynx, and then behind the oral cavity, we have the oropharynx, oro like oral, and then the laryngopharynx, like the larynx, the voice box that's found down here. Those are your portions of the esophagus. The esophagus will move down and then it'll pass through the diaphragm through the esophageal hiatus. Okay. A hiatus just means a short break or a pause. So we get this short break in the diaphragm to allow the esophagus to pass through, and then we'll connect with the stomach. Before moving on to the stomach, I want to touch on the omenta here. It might be a new term to you. I believe on your structures list, you have both the lesser omentum and the greater omentum. So the lesser omentum, it connects the liver to the stomach. I guess the duodenum too here. So we have the duodenum of the small intestine and the stomach, and that'll connect them to the liver. And then we have the greater omentum, which attaches the stomach, okay, to the transverse colon. Okay. And basically these omenta are like these aprons of fat. That's why they're showing this yellow adipose tissue here that hang down. So you'll have one here, the lesser omentum, and then you have this big apron of fat here, okay, covering the intestines. Now we can move on from the esophagus to the stomach. And again, we'll see both chemical and mechanical digestion occurring within the stomach. So food will enter from the esophagus here via they call it the cardiac sphincter. So this is your cardiac sphincter here, where it would enter into the stomach. There are three main areas or sections to the stomach. The first is the fundus, and the fundus is the area that's found above the cardiac sphincter. So if we have the sphincter here, it's this area here. There's pacemaker cells here. They initiate the slow contractions associated with the digestion or mechanical digestion of the stomach. So those will originate here and then move through the other sections of the stomach in like a wave-like action. The next portion we have of the stomach would be the body of the stomach. Okay. And this is primarily storage of your digested materials, so we can distend that bag a lot. And then the lower section is called the antrum. And in the antrum here, this is where we see really strong muscle contractions to really mix and digest that food. And then ultimately it'll be pushed through the pyloric sphincter and it'll enter the duodenum, which is part of the upper portion of your small intestine. All right, so we said that the GI tract, we said that that muscularis layer, the muscular layer of the GI tract wall, was 2 layers. Well, here's an exception. Within the stomach, there's an actual a third layer, and that is the oblique layer. So the most internal would be oblique, and that's followed by this circular layer then, and then we have the longitudinal layer. Okay. The oblique layer adds just another dimension to those contractions. So that's going to help aid in the mixing and the churning that occurs within the stomach. You can hear my wife and son arguing in the background. So here we can also see these gastric folds, and they allow the stomach to distend. So it provides more area for the stomach to accommodate incoming digested material, and they help increase the surface area of the stomach as well. All right, so from the stomach, we'll move into the small intestine, and we'll begin by entering into the duodenum. So if we have our stomach right here, we'll move through the pyloric sphincter into this upper section of the small intestine, the duodenum. That'll be followed by the jejunum. The duodenum is very short, so small. I think it's about a 10-inch section of intestine. And then we'll move into the jejunum. So it's this middle portion. Okay. And then that'll be followed by the ileum. Okay. And that'll be this lower portion. So if you have trouble remembering that, just remember the coolest new DJ in town, DJ Ileum. Right. So jejunum or duodenum, jejunum, ileum. DJ ileum. Okay. Then we'll move from the small intestine. Actually, we should talk about some more anatomy, specific anatomy to the small intestine here. So There are 3 structures within the small intestine that increase surface area for absorption of materials to occur. The majority of absorption of nutrients occur within the small intestine, that part of your GI tract. So the anatomy we're going to talk about are the circular folds. Okay? We can see these here as these bump-like ridges that are found lining the inside of the small intestine. Then we'll talk about villi and microvilli. So these circular folds, they're also called plicae. I believe both terms are on your structures list. They do a couple things. They act as speed bumps to slow material that's moving through the intestines down to bide time for absorption. And they also increase the surface area of the small intestine. And that's actually going to give us a 3-fold increase in surface area, as if this were compared to just a hollow tube, if your GI tract were a hollow tube. So the circular folds will increase that surface area 3 times for that material to interact. Excuse me, I'm getting over a cold. All right, next we have the villi. So if we zoom in on one of these plicae or circular folds, we can see these finger-like projections atop them. And these are called villi. Intestinal villi, V-I-L-L-I. And these again act to increase the surface area. And they're going to increase our surface area another 10-fold. And then if we zoom in on one of those villi, we can see that the simple columnar epithelial cells, okay, that make up those villi have these little hair-like projections upon their apical surface of those epithelial cells, and they call those microvilli. Or you may hear the term brush border, because it looks kind of like a brush, teeth of a brush, of a comb. Okay, and they act to increase the surface area another 20-fold. Okay. So you can imagine if we compared this then to a hollow tube, we have these anatomical structures here that increase surface area 3 times 10 times 20. And so we increase our surface area 600 times to allow for better absorption, okay, by having those specific anatomical structures associated with the small intestine. Here we can really see, we have a cross section here. We've opened up part of the small intestine. Here you can really see those folds, or the circular folds of the plicae. Here's a histological prep. So we can see those circular folds here, and then we can see those finger-like projections of the villi upon them. And then if we had a really good microscope, we'd see the brush border or the microvilli. Okay, another view there. Single villus. All right, that moves from the small intestine into the large intestine, which is also called the colon. Okay. We got 3 sections here. We got the cecum, the colon, and the rectum. So if we move from the small intestine, which remember we said ends in the ileum, we'll connect to the colon via the ileocecal valve. Sounds tough, but it's easy to remember because we're moving from the ileum to the cecum, so ileocecal. Okay? And that'll connect to the cecum of the large intestine. We'll get chyme entering from the small intestine. So that's our digested material now that it's been mixed with these enzymes. And it will move into the large intestine. And then we have our colon, which is U-shaped, and we have these 4 segments. It's not doing a great job showing you. Maybe I'll progress to the next slide here. So here's our 4 sections of the colon. We have the ascending, which ascends, the transverse, which transverses, the descending, which descends, and then the sigmoid. Sigmoid means S-shaped. So you can see they didn't get too creative with the naming here, thankfully. And then we end with the, I'll flip back, the rectum. And rectum just means straight, rectus. It's a muscular tube, holds the fecal matter. Okay. And then as part of that rectum, if we look at the anal canal, we can see that there are two sphincters. So there is an internal anal sphincter, okay? And that's comprised of smooth muscle, which is involuntary. And then we have our external anal sphincter, which is skeletal muscle, which then is voluntary. So thankfully, we have voluntary control of when to initiate or allow for defecation, right? Good thing to have voluntary control over. So we have that ring of skeletal muscle there. We already went over those. Guess I should show you the little pouch-like structures that we see. Like if you were to sketch an intestine, we always sketch them kind of like, for whatever reason, you'd be stretching an intestine. Those little pouches, those are called haustra. Okay, so plural, here's a haustrum, singular. Haustra are these pouches of the large intestine. A little bit different from the small intestine, we can see that there are no villi present within the large intestine. Instead, we see lots of these goblet cells that secrete mucus to help things move along. Again, this is histology, so you don't really need to know it until we get to lecture. Okay. Mentioned before, sigmoid colon, the rectum, which means straight, and then we have an internal and external anal sphincter. We also have accessory digestive organs that help aid with digestion, but they're not part of that GI tract tube. Okay, so a big one of these is going to be your liver. The liver actually has 4 lobes, and here on the anterior surface, we can see there are 2 that you can see, the right lobe of the liver and the left lobe of the liver. And those are the only 2 that you need to know. The right lobe, if we were to look at the posterior side, there are 2 others. We'll talk about them in lecture. The liver, we just talked about, secretes bile. It's one of the many things it does. And that bile is going to flow through the common hepatic duct. So if you can picture, we have our liver up here. It's going to produce bile, and then it's going to flow via the common hepatic duct. And during times of food, it could flow right into the, during times of eating, it could flow right into the small intestine, the duodenum. Bile helps break down and emulsify lipids within our food. Okay, but also, it can be stored within the gallbladder if it's not mealtime. When it is released, the bile at mealtime, then it'll flow through the bile duct and enter into the duodenum. Okay, so bile produced in the liver flows through hepatic duct, can be stored in gallbladder, and then released via the bile duct at mealtime. Hopefully I didn't make that too confusing.
All right, real quickly, I want to give you a little bit of background on the liver here, relating to how it receives blood from 2 different sources. So we'll see that oxygenated blood, leaving the aorta, will flow into the hepatic artery. Hepatic, again, meaning liver. So this is how oxygenated blood is going to be brought to the liver. Okay. But we'll also see the hepatic portal vein. And this is where venous blood from the digestive tract is going to enter the liver for processing and storage of absorbed nutrients that we've gotten from that GI tract. And then we'll see there's a hepatic vein that leaves the liver, and that'll flow up to the inferior vena cava. We mentioned the pancreas has both endocrine and exocrine function. Just a quick touch on the endocrine function. We have these clustering, and they're shown here in violet, these clusters of pancreatic cells. And those cells, termed the islets of Langerhans, they secrete insulin and glucagon. You've heard of these probably before. Insulin allows the cells to absorb glucose from the blood, while glucagon triggers a release of glucose from the liver.
All right, so I had drugged those slides in there from one of my other PowerPoints, not realizing that my audio was still attached to it, but that's fine. That's basically what I would have said anyway. So another accessory digestive organ then, in addition to the liver, would be the pancreas. And we have both endocrine and exocrine function associated with the pancreas. Endocrine, as you know, would be like insulin and glucagon. And then the exocrine, meaning secreted to inside the lumen, the hollow part of the body, which is technically external, right? Hence exocrine versus endocrine. That'll include things like digestive enzymes. And I sound congested. So that's basically what I wanted to point out with those structures. Let's see, what else do I have here? Okay, the last thing I'll point out here are these papilla. So we have major and minor duodenal papilla. So the major is going to be found, let's see, I thought I had an image. Oh, here it is. Okay, good. Okay, so here we're showing our major duodenal papillae. And this is where bile and pancreatic juices are going to enter the duodenum. Now there's a smaller one above it, the minor duodenal papilla. You can see it perhaps better down here. This is also called an accessory pancreatic duct. So we will get a little bit of those pancreatic secretions secreted there as well, but most will come through this major duodenal papilla. All right, that's what I got for that. Are there any questions about anything? Sorry for the disruption from my son. It's been wild here. So
it's okay.
Well, if there's no questions, as always, feel free to email me. Otherwise, I believe next week is also a review week. And then we'll pick up from there.